Hello, everybody. First of all, let me introduce to you the design concept of TonExchange, the design structure and the functions that have been implemented so far. The biggest advantage of the Ton blockchain, over other public chains, should be its cheap gas price and fast speed. Our design goal is to allow users to trade on the Ton blockchain as fast as they do on a centralized exchange, with low fees. At the same time, the security of their funds is guaranteed in a decentralized way, and each order is real. This is the biggest goal we want to achieve. We first introduce its design pattern. The current exchange adopts an order book trading model. From my personal point of view, the order book transaction model is better than the automatic market maker transaction model. Judging from the current market feedback, although the AMN model is very popular, it has many shortcomings of its own. These shortcomings are completely avoidable in many traditional financial products and centralized exchanges. So this is why, although the DEFI exchange is very popular, its total trading volume and market value are much less than that of centralized exchanges. Our current exchange design model is to change this situation. The user can place an order and give the order a certain price, so as to avoid the price slippage caused by the AMM model. Price slippage will cause market makers to lose profits, because if the same trading pair exists on both a centralized exchange and a decentralized exchange, then after the price slippage reaches a certain percentage and remains for a certain period of time, it will be inevitable. It will bring losses to the market maker, and the more transactions, the more losses will be caused. Price slippage will cause market makers to lose profits, because if the same trading pair exists on both a centralized exchange and a decentralized exchange, then after the price slippage reaches a certain percentage and remains for a certain period of time, it will be inevitable. It will bring losses to the market maker, and the more transactions, the more losses will be caused. Therefore, market makers on all current EFI exchanges either trade the same trading pair with a large price difference, or trade the only trading pair in the AMM liquidity pool. Order book transaction mode can completely avoid such problems. As long as there are enough orders, this trading model will bring users exactly the same experience as a centralized exchange. Below, we talk about how this exchange achieves this goal. The entire exchange is divided into two parts. The first part is user deposit and cash withdrawal. As you can see on the picture, the user first deposits the token into the exchange wallet. The exchange wallet can be generated by the user. While depositing before, users can freely add the tokens they want to trade to the exchange. After adding the token to the exchange, transfer the token from your wallet to the exchange wallet, and then call an interface in the wallet to implement the token deposit in the wallet to the exchange smart contract. Similarly, when you want to withdraw money, you can also send a withdrawal instruction to the exchange smart contract through your own wallet, and the exchange will check your exchange balance if it receives the instruction. If your balance is greater than or equal to your withdrawal amount, the exchange will call the exchange wallet to transfer the token to your wallet address. Our design philosophy is to put all transaction operations in a smart contract method to avoid message transmission to complete the transaction, because in the Ton blockchain network, the sending of messages is unstable, and the message sending may fail, or it may be sent to an incorrect address. If we put the transaction between the smart contracts of the two wallets to complete, it is very likely that the transaction is only completed on one side. The seller's token is sent out, but the buyer's token is not received. Of course, we have other measures such as unbound messages to handle failure messages, but this will greatly increase the complexity of the transaction. If we put the transaction between the smart contracts of the two wallets to complete, it is very likely that the transaction is only completed on one side. The seller's token is sent out, but the buyer's token is not received. Of course, we have other measures such as unbound messages to handle failure messages, but this will greatly increase the complexity of the transaction. So we gave up this design. Our design first allows users to deposit and withdraw funds to the exchange wallet, and transfer the token balance in the exchange wallet to the exchange smart contract through some interface calls. Let's continue to look at the second picture. After completing the first step, we will form two token pools in the smart contract. One is the fungible token pool and the other is the non-fungible token pool. We can see from the competition requirements that any TIP3 token is supported, so we try our best to support all TIP3 tokens. I think this is the only work in this competition that supports both fungible token and non-fungible token. I think this is the only work in this competition that supports both fungible token and non-fungible token. After the user completes the deposit, the user can perform some transaction operations through their own wallet. I think this is the only work in this competition that supports both fungible token and non-fungible token. After the user completes the deposit, the user can perform some transaction operations through their own wallet, such as placing an order, canceling an order, and completing an order. At the same time, these trading interfaces can be exposed to external SDK API calls, which can easily access web interfaces and other dApps. The user sends a put order command to the Exchange smart contract through the wallet. After the Exchange smart contract is received, it will check his account balance and whether the order can be completed. If there is sufficient balance, it will check what he wants to buy. Is the token exchange already supported? If it is already supported, it will place a new order in the order pool. This order pool can be queried by any external message. If someone wants to fill order from this order pool, either he must first deposit to the exchange wallet, and then call the fill order method to complete the order from his wallet. In the overall design of this exchange, we can guarantee that our transaction is completely successful or completely failed. I personally believe that the first element of a decentralized exchange should be to ensure the security of user assets and user transactions. If any transaction is unilaterally successful, it is unacceptable for users, especially on the TON blockchain. It can send tokens to wrong addresses or inactive addresses. In order to avoid similar errors in transactions, we think our design should be the best. In our design, there are only two operations that need to be completed by passing messages. One is deposit and the other is cash withdrawal. We have added on-bound processing for these two messages to ensure that they are executed correctly. Therefore, we have enough confidence in the security and stability of our exchange. Below we introduce in detail how to test on the TonExchange node. Below we introduce in detail how to test on the TonExchange node. We can get the SE node that I have deployed from the document. Through the Docker command, we can download the node. We can see that the Exchange smart contract on the node already supports 3 tokens. Now we want to add a new token into the Exchange. Register a new token through the reg token to exchange method, then through get all support tokens. Check all the tokens again. You can see that the new token has been added successfully. Then check the exchange wallet address of the token. With the wallet address, we can recharge to the address. Now we transfer 50 tokens to the new wallet. Then check the balance of the wallet address on the Exchange smart contract. You can see that the address has been successfully deposited. You can perform trading operations. Then we added the new order. Number 3 is our newly added order. After the put order is successful, we can fill the order. After the put order is successful, we can fill order. Ensure that the gas value of the fill order is greater than 1 ton, and then submit the fill command. After the filling is completed, and the order is executed, we can check whether the order balance is correct. As you see, all is fine, so, this all for the TonExchange first stage.